All right, guys, I'm going to try to go through these pretty quickly so that you have some time to work on your homework today. But our next unit that we're starting on is all about area of different shapes. We'll start with some pretty simple ones here, and then we'll do some that you probably don't know next week. So starting with just rectangles, parallelograms, triangles, rhombuses, etc. These are ones you guys probably already know, but we're just going to quickly review them. So area of a rectangle, hopefully we know that is just the base times the height, right? With a rectangle, all of our angles are right angles. Our opposite sides are congruent. So when we talk about the base and the height, and you'll see this as a common theme through all these shapes today, the base and the height need to be perpendicular to each other. That's why we call it a base and a height. So with a rectangle, it's pretty simple. It's just the two different sides, right? To fill in a table here with our missing heights or areas, the first one, we've got the base and the height. Multiply those together. That will give us 36 meters squared. For the next one, we're missing the height. So if I take the area and I divide by the base, then we get a height of 6 centimeters. The next one, we've got base and height. To find the area, we're going to multiply those two things. We've just got radicals involved in this one, but we're going to do 4 radical 3 times 5 radical 3. That would be 20 times just 3, which is 60. So our area there would be 60. And then the last one, we've just got variables involved. We're going to do y minus 2 times y. And if I distribute that in, we would get y squared minus 2y for our area. Write it over here as well. Okay, just filling in those boxes. You guys should be able to do those. Next one, find the area of this rectangle. This one, we actually don't know either the base or the height. You can kind of ignore that x right there. But I do know the length of the diagonal, and I know that we've got a 30-degree angle here. Since this is a right triangle, or a rectangle, I also know that that's a right angle, which makes this a right triangle down here, and it's a 30, 60, 90 triangle, right? So remember, across from the 30-degree angle, this would be our short leg. Across from the 60, this is our long leg, and the 8 is our hypotenuse. To get the long leg and the short leg, well, I know that the hypotenuse is 2 times the short leg. So if our hypotenuse is 8, then that would mean that our short leg has to equal 4, right? Just 8 divided by 2. And then our long leg, I can get by doing the short leg times radical 3. So our long leg would equal our short leg, which we now know is 4 times radical 3. So this side would equal 4 radical 3. So now if I want to find the area of our rectangle, we can do the base, which is 4 radical 3, times our height, which is 4. So then we get an area of 16 radical 3. Ta-da! Okay, use your 30, 60, 90 rules there. So sometimes you've been given a diagonal. In this case, it was 30, 60, 90. We could use those rules. It could be that that angle is 22 degrees. If that's the case, you can use your trig functions, your SOHCAHTOA, to get the other two sides of the triangle. Okay, area of a square, again, pretty straightforward. It's also base times height, but if you'd rather write it as the side length squared, you can do it that way as well. So if I've got a square, again, all 4 right angles, but this time all 4 sides are the same. So when we think about base times height, it's just our side length squared. So you can think about that way instead. Again, sometimes you might have to think about a diagonal of a square. So for this one, it tells us that we've got a square. The length of the diagonal is 6 feet. Again, we've got a right angle up there because it's a square. If we know that these two sides are the same, we know that that is a isosceles right triangle. So that means that these two angles have to be 45 degrees. So now we've got a 45, 45, 90 triangle. The rule for that one says that our hypotenuse is equal to the leg times radical 2. So if our hypotenuse is 6, and I'm trying to find, we'll call this S for our side length, side times radical 2. I can divide by radical 2 on both sides. So we get 6 over radical 2 for our side length. I need to rationalize that. So I'm going to multiply by radical 2 over radical 2. So then our side length would equal 6 radical 2 over 2. And then I can simplify that and get 3 radical 2. So then the area of our square would be 3 radical 2 squared, which is 9 times 2, which is 18. Okay, so you can use the diagonals. You don't have to have just the two sides. We can use the diagonal to get those to then find our area. Next one on a triangle. Again, hopefully this is one you know well. A triangle is half of a rectangle or half of a square. So to find the area of our triangle, we're going to do 1/2 base times height. The one catch with a triangle is your base and your height have to be perpendicular to each other. So if I've got a right triangle, here's my base, here's my height, right? If I've got a triangle that's maybe not a right triangle, something more like this, and I want to call this my base, then I've got to draw in an altitude to make myself a height, right? So you got to be careful about picking your base and your height and making sure they're always perpendicular to each other. Okay, so in this first example, if I want to do base times height of this triangle, I would not do just the 10 and the 13. If I make 13 my base, then they've got this perpendicular drawn in over here to the base, so the 8 would be our height. So to find the area there, I'm going to do 1/2 of 13 times 8. That would be 1/2. Let's see, of 8 is 4, so 4 times 13 would give us an area of 52 for that triangle. Okay. Find the area of an isosceles triangle with a base of 10 and a perimeter of 34. Okay, so an isosceles triangle, remember, our two sides are the same. If the base is 10 inches, if the total perimeter is 34, I can take 10 off of that. That leaves us with 24. And if I divide that in half, that makes each of these sides 12, right? Now again, I need a height of my triangle, but I've got to make it a perpendicular height. So I'm going to draw in that altitude. With an isosceles triangle, when I draw in that altitude, that splits our base in half, or it bisects that bottom segment. So that means these are each 5. So now I've got a right triangle that I can solve here, where this is 5, this is 12. And we're looking for this other side, because that'll be our height. So we can call that H, maybe. I don't know if it'll let me erase it, but we can call that H. So I can do my Pythagorean theorem. 5 squared plus h squared equals 12 squared. That will make h squared, see, 144 minus 25, that's 119. So then that means our height would be the square root of 119. Then to find our area, we would do 1/2 times our base of our whole triangle, which is 10, times the height, which we just found to be the square root of 119. So the area of our triangle would be 5 radical 119. Ta-da! Okay. Next one, find the area of a 30, 60, 90 triangle with a hypotenuse of 14 yards. So 30, 60, 90 triangle, you can make either one of these 30 and 60. Our hypotenuse is 14. Again, with your rules for 30, 60, 90, the short leg, or the hypotenuse, is twice the short leg. So if our hypotenuse is 14, that means my short leg would be 7. And then if my short leg is 7, I can get the long leg by multiplying by radical 3. So that would be 7 radical 3. So then the area of our triangle would be 1/2 the base of 7 times the height of 7 radical 3, because those are the ones that are perpendicular. So we get 1/2 times 49 radical 3, which I could write as 49 radical 3 over 2. There's our area. Okay. All right, so area of just a parallelogram. We've talked about a rectangle and a square, which are both parallelograms, and how their area is just the base times height. Same exact thing for a parallelogram. It is always base times height. Again, the catch, like with the triangle, is that your base and your height have to be perpendicular to each other. So if I've got a parallelogram here, remember that means that we've got two sides or opposite pairs of sides that are parallel. To find the height, so if this is my base, I've got to draw in a perpendicular to get that height. Okay, If I draw in that same perpendicular over here to see that one, then we can see, sorry, that, come on, switch to the highlighter. Get it to switch there. This piece here is like our rectangle, right? So if I take that triangle off the parallelogram, put it on the other side, you can see how it's a rectangle and the area is still base times height. Okay, so if I want to find the area of this parallelogram, we've got a base down here. It's broken into two pieces, 2 plus 10, so the total base would be 12. To get my height, I need this section here because that's the perpendicular part. And again, we've got a 30, 60, 90 triangle, right? Our short leg is 2 because that's across from the 30. So then our long leg, which is our height over here, would be 2 radical 3. So then to get the area of our parallelogram, we're going to do the base, which is 12, times the height, which is 2 radical 3. So we'd get an area of 24 radical 3. Area of a rhombus. Now, a rhombus is also a parallelogram, so you can always find the area of a rhombus by doing the same thing, by doing base times height. But there's another formula for area of a rhombus. You can do 1/2 of the product of the diagonals. And the reason that works out is in a rhombus, we've got all 4 sides the same, and our diagonals here, we create 4 different triangles. And when we go to find the area of those triangles, they're all the same because we're doing the half of each diagonal times half of the other diagonal. And then when you add all 4 of those together, you end up with 1/2 the whole first diagonal times the whole second diagonal. Okay, so if I want to find the area of a rhombus with a diagonal of 30, draw in my rhombus here. We know all 4 sides are the same. It also tells us here that the perimeter is 100, so I can split that up into 4 sides. So that means that each side is going to be 25. Right? And then if I draw in one of my diagonals, I know that that's 30. If I'm going to use my 1/2 diagonal 1 times diagonal 2, I'm also going to look at the other diagonal. In a parallelogram, we know the diagonals bisect each other. So one of these would be 15 and 15. We're looking for the other one, call it x and x. We also know in a rhombus that the diagonals meet at a right angle. So now we've created ourselves a little right triangle here. Draw that in. The hypotenuse is 25. One of the legs is 15. So to solve for the other one, you get x squared plus 15 squared equals 25 squared. That's 625 minus 225, so x squared is 400, which means x is 20. So then that means that our other diagonal would be 40, right? It's twice that. So to find my area, I'm going to do 1/2 the first diagonal, which is 30, times the other diagonal, which we just found is 40. That's, let's see, 1200, and then half of that would be 600 for the area of our rhombus. I guess we can put units squared on there. Okay. All right, then our last example here, kind of putting a couple different shapes together. We've got 2 triangles off on the side. These 2 sides of our triangle are perpendicular, so to find the area of each triangle, we could do 1/2 times the base, which is 8, times the height, which is also 8. So that's half of 64, which is 32, right? I'll be careful about the piece in the middle. A lot of people want to go ahead and assume, well, then that's just 10. It's a square. You can't assume that. We don't know that that's 10, but we do know that that triangle on the side is a right triangle. So to find that other piece there, it won't erase. Erase it. Call that x. It's not 10. There we go. I can use my right triangle and do Pythagorean theorem. So I'm going to do 8 squared plus 8 squared equals x squared. It's going to give us 64 and 64, which is 128 equals x squared. If I take the square root of that and simplify it, that's 8 radical 2 would be that length. So it's not 10. It's not a square. It's actually a rectangle. Let's get the area of our rectangle. I'm going to do base times height. So 10 for one of my sides times 8 radical 2 for the other side which will give us 180 radical 2. So then our total area, right, is we've got 2 of the triangles, so 32, plus another 32, plus the rectangle is 180 radical 2, which would give us 64 plus 180 radical 2. I can't add the 64 and the 180 because the 180's got the radical 2, so that is our exact answer, or we could plug that into our calculator to get an approximate if we needed it. Okay, hopefully that helps give you a couple examples to work with as you work through the homework. Notice that there are 2 sections that you're doing in the homework today, so make sure you go through both of those. I will see you guys in our next class.